Hey guys, so today we are going to take notes on factoring a little bit more, um, and then what we do once we factor something, how we actually solve it. So this should be page 23 in your notes. I did not put my transformation lab in my original table of contents, so that should be pages 15 through 17. I'll adjust that later, but this should be on page 23 at this point. So let's turn to that real quick. I did post a copy of this on the classroom. The examples aren't filled out, so if you printed that, just follow along and then fill out the examples with me. So here we are on page 23 where we are solving quadratic equations for the roots. So a regular quadratic equation in standard form is ax squared plus bx plus c, and you want to make sure that it's all set to 0. If it's not set equal to 0, then you're just working with the expression and just kind of getting used to how it looks and making sure everything is there. Once you've actually got an equation or it's set equal to something, you want to make sure that it's equal to 0 and that everything is all on one side together, set equal to 0. Once we factor it, though, that's where we get those two sets of parentheses and our x values are split, and then we have some sort of number there. If you have a GCF or a greatest common factor that you can pull out of all three terms before you start factoring, you want to pull that out first. That'll be up front. So here are the steps to factoring and then solving for your roots. So always make sure that your equation is set equal to 0. And again, if you haven't been working with equations that are set equal to 0, those are just expressions, and you can still factor them. But whenever you do see an equal sign, make sure that it's 0 and there's not a random number over there. Check to see if there is a greatest common factor between all three terms. Again, common is the key word. It has to be between all three. If it's not something that all three share, then there is not a GCF that you can pull out. If you can pull it out, you're going to put it in the front. And then everything that's left will be in parentheses. At that point, you will do the inverse box method on all three terms that are left in the parentheses. You will write them in factored form, making sure that you bring that GCF that you pulled out, you're going to put it back in the front. And then at that point, once you've got it in factored form, like we've practiced, you're going to set both of those parentheses equal to 0. So this is the new part, step 5, setting them to 0 and solving for x. Once you've done that, those are what we call roots, which is going to be important when we start graphing these quadratic equations. So knowing how to go from standard form to factored form, and then how to solve, factor them, and get your roots is our next step. So I've got 2 examples here for you. The first one is 7x squared plus 6x minus 1 equals 0. Now looking at this, the characteristic that I see is a squared symbol, so I know from the get-go that this is a quadratic equation. It is set to 0, so I'm just going to start trying to factor. There's not a GCF. There's nothing common between them that I can pull out. The only number that can go into 7 and can also go into 6 and can also go into 1 is just 1. So if I divide all these numbers by 1, it's not going to change anything, so I'm just going to go from here. So again, you're looking for 2 numbers that is going to multiply to give you a and c, which is 7 and -1, which is just -7, but also add up to give you 6. So it's going to multiply to give me -7 and add to give me 6. And what would that be besides 7 and -1? So 7 minus 1 is 6, and 7 times -1 is -7. So when you come down here and you make your box, as always, you bring your ax squared here, and you bring your c value here, and this middle term gets split into these 2 numbers that we found. So we've got the 7x and we've got the minus 1x. At this point, we start pulling out our GCFs in each column and each row. This column, the only thing that they both have in common is a -1. And in this column, they both have a 7 and at least 1x. I can't pull out 2 from both because this bottom one only has 1. Now, if we look at each column, the only thing I can plot that can go into a 7 and a -1 is just a 1. 1 can go into 7 and 1 can go into -1. And the only thing, again, up here that can go into both is a 1 and then an x. If you want to put a 1 in front of this, you can. It doesn't change the value of it, so we typically don't do that. Now, at this point, these would be your factors. So you've got 7x minus 1 and then x with a positive 1. Again, if there's no negative symbol with your number, when you're plugging it in over here, it's a positive. This is the factored form of this quadratic equation. Now, from this point is where you're going to start solving for your roots. So each one of these gets set equal to 0. So we have 7x minus 1 equals 0, and x plus 1 equals 0. And at this point, you're just solving for x. So I would bring this one over. So I now have 7x equals 1, divided by 7, x equals 1/7. And then over here, subtract this 1, bring it over, x equals -1. So these are called roots. This is factored form, and to go a step further is to find the roots. When we graph this, these numbers are important. They tell us where we're putting dots at on our x-axis. They're called roots. So that's important to know moving forward, to go from factoring it to now solving those factors. And then this last example, again, these are both a values greater than 1, which we can do. This inverse box method is super helpful at helping us figure out how to do that. But also remembering, if there's a GCF, you pull it out always, and then making sure it's set to 0. So in the second example, I do see a squared, so I know it's quadratic, but it's not set equal to 0. So I need this to come over here. And to bring this over here would be to subtract 30. Once I do 30 minus 30, that will be 0. And it's now on this side. So my actual equation will end up being 2x squared minus 4x minus 30 equals 0. Because 30 minus 30 is 0. So now this is right, and this is proper. Everything is set to 0. So before I start saying, okay, what two numbers multiply to give me this and add to give me this, we need to say, is there a GCF I can pull out? And these all look like even numbers, so I can pull out a number that goes into all of them. And you can never go bigger than your smallest number, so we're going to look at 2. 2 can go into 2, 2 can go into 4, and 2 can go into 30. So I'm going to pull this 2 out and divide everything by 2. Everything. And so now that 2 is going to come out, and we're going to say, well, whatever's left over is what's going to come down. We're basically reducing everything by 2, since that was our GCF. Well, 2 divided by 2 is just 1, so that just leaves us with 1x squared. -4 divided by 2 is -2, bring down that x. And -30 divided by 2 is -15, right? So I basically took all these numbers and divided them by 2 and pulled the 2 out front. Now, if I wanted to go back and distribute this back in, I would get back up to my original answer, or my original equation. But I don't want to do that. I'm trying to factor this out and find the roots, and it's going to make my life easier if I know my greatest common factor to pull out before I start trying to factor. So now, we look at our steps. We made sure it was set equal to 0, and we checked to see if there was a GCF that we pulled out. And now we do the inverse box method. So now to this part left in the parentheses, I'm going to say, okay, I need to find a number that's going to multiply to give me 1 times -15, which is just -15, and add up to give me -2. Because again, we're not looking at this. We're looking at our new equation inside the parentheses. That is a simplified version. So I know that 5 and 3 multiply to give me 15, and I can somehow make them add up to give me -2. Would 5 minus 3 give me -2? No. So I'm going to put the negative with the 5. -5 plus 3 is -2. And -5 times 3 is -15. So those are my two values. Now at this point, I come down here and I make my box. I put the A value and the C value in the box. And then I plug these two in right here for what we gathered would work out to give us that B value. So we have -5x and 3x. Remember, if it's got to add up to give us that middle value, we have to put the x's with it. Sorry about the lights. So now we pull out our GCF. What's the greatest number that can go into 3 and -15? And again, you can look at your factor sheet if you want to, but I know the only multiples of 3, the only factors of 3 are 1 and 3. 1 times 3 is 3. There's no other way to get to 3. So is 3 a factor of 15? 3 times anything get me to 15? 5, right? So 3 is a factor of 15 and 3 is a factor of 3. So I can pull a 3 out. And now let's look here. They both have at least one x. I know that. And the only number that can go into both is a 1. You can't ever go bigger than your smallest number, and there's an invisible 1 right here. So that's going to just be a 1. Now if we look at this row, I know they both have an x. And again, I can't ever go bigger than my smallest number, and there's an invisible 1 right here. So that's going to be that. And then 5 can go into 5 and 5 can go into 15. They're both negative, so I can pull out a negative 5. But they both don't have an x, so I can't pull an x out. But the only common factor that they both have is 5. And since they're both negative, I can pull out that negative. So now when I write these two factors, we have an x with a positive 3 and an x with a negative 5. And don't forget to bring this GCF that we pulled out at the very beginning, you got to bring it back down. So this is our factored form now. Now, still, the only thing we do is set what's in parentheses equal to 0. We don't set this 2 to 0. That's just necessary so that when we work this out, we will get back to the original. We can't just forget about it. But at this point, we're going to set these two equal to 0. So x plus 3 equals 0, and x minus 5 equals 0. Now to solve, we have to get it by itself. So in this example, x equals negative 3. And in this example, x equals 5. So these two are our roots. And if you wanted to, I'm going to do this in pencil. If you wanted to double check that this will send you back to your original equation, give it a try. This gets distributed to both of those, which would be 2x plus 6. So I just distributed that 2 in and got this right there. So I've distributed the 2 into the x and the 2 into the 3. And then over here, if you wanted, you could box method this out. Not inverse box, but just regular box. 2x, 6x minus 5. So remember, one set of parentheses goes on one side, the other goes on the other. 2x times x is 2x squared. 2x times negative 5 is negative 10x. X and 6 is 6x. Negative 5 and 6 is negative 30. 2x squared, that combines to give you negative 4x minus 30. 2x squared minus 4x minus 30. So this does work. And again, the only reason we bring that 2 or that GCF back down is to keep the statement true. This is here to keep the whole statement true. This has nothing to do with finding our roots. But we can't forget about it and just not bring it down, or else our statement is no longer true and we're not going to get back to our original equation. So yeah, that's how we take the equations that are given to us and we factor them, and then we take those factors and find our roots. So that's the whole reason that we factor them out. If you were ever wondering, why do I need to take this equation that's in standard form and put it in factored form? What does that do for me? Factored form helps you find your roots. That's really the only purpose of it. And then if it's in factored form and you want to get it back to standard form, you would just use your regular box method. We do inverse box to find the factors. But if they're given to you, you would put those on the outside and just multiply them together to fill in the box like normal. But I don't know why you would need to go backwards. Factored form tells us a lot of information. So that's it for your notes today. I'm not sure if there's any work for you to do today or not, but make sure that you get this down in your notebook and you do anything else that is posted for today, if anything else is posted. Thanks, guys.